Okay, now we're recording, so watch what you say. So the course.
When you say recording, like...
I'm recording the desktop and my voice. And I'll put them on a YouTube. I'll put them on a YouTube channel at the end of by midnight tonight. It'll be there. Okay. We're using two texts. We're using. I don't want to hold this up because it's propping up my laptop at the moment. But we're using the 6th edition of Savage. Hopefully you're able to find that, or you already had it from when you took programming with me. It's got some stuff sort of sprinkled throughout that is going to be useful to us. We're not really going to be following in any kind of linear way. It's just going to be a reference. And then we're going to be using David Guichard's data structure notes. Again, we're not going to be following them religiously. We will follow his notes much more linearly than we'll be using Savage's book. I guess if we were to say that this course we're tracking a text, it's more closely tracking David Guichard's notes than it is the Savage book. But the Savage book has some stuff in there about C++ that David doesn't really address directly, and that I think might be useful. Everything about the course can be found at this webpage, caret.whitman.edu/270. I don't use Clio. I roll my own web pages. I don't know. I've done it for as long as I can remember, and I'm too old to change now. If you go to the if you go to the syllabus link there from the web page, you see a table. Today is Monday, January 4th. You see some readings that I've suggested. You see some homework that I've suggested, and then any supplemental links that I might want to throw in there, I'll try to put in that second to last slot. And then the work that I've assigned in the homework box is due on January 23rd. That's next Wednesday. We have Monday off. It's due by midnight of that day. And I'll just be judging that due date by the timestamp on the files as you submit them to me. And I'll show you how to submit them to me later in the period. Your first homework assignment has some stuff that you have to turn in about linked lists, and then some supplementary stuff at the bottom that you don't have to turn in, but you're going to have to learn to get through this class. No matter what programming environment you're using right now, I want us all to start with this programming environment that I'm about to describe. And that is essentially logging into the MATLAB using a text terminal and doing everything from a text terminal, at least to start out with. I want us all to start from a common technological foundation, and then you can branch out from there. I'll let you know when you can branch out, but it's not going to be too long. I want to make everybody suffer with the command line, at least for a little while, and suffer with a very straightforward text editor called VI/Vim. Some people like VI and Vim. Other people recoil in disgust. Why am I doing this? To be honest, it hasn't changed in 25, 30 years, and in fact, it seems to be becoming more true that to be successful in computer science, you need to be able to navigate at this level. You need to be able to navigate around a computer at the command line, at the text level. These programs that I'm using in Windows here, these are what we call GUI programs, graphical user interfaces. And they're lovely. They are extremely powerful, and they let you get lots of stuff done. But what you lose by continually operating in this environment is it kind of separates you from what's really going on the computer. And I want to at least expose everyone in here to that before we move on. So to do that, one of the things I'm going to talk about today are these supplementary exercises. Number one, learn how to get into the MATLAB using a text terminal. Number two, some basic Unix commands once you get into that text terminal. Three, how to use the VI editor to edit files, save files, And not listed here, but probably in this class period, I'll show you how to compile at the command line, run your program at the command line, and finally submit your program to me from the command line. Okay. So you can see my goals there. I'll let you read those. The homework statement is fairly plain vanilla. Let's talk about late policy. Late policy, people that have had me before are already familiar with this. The way it works is I have a due date, and your program is due, but it has to have a timestamp by midnight of that due date. If it comes in the next day, I grade your program, I give you a percentage out of 100, and then I subtract 1 point for being a day late. If it's in 2 days late, I subtract 1 plus 2 points, or 3 points for being 2 days late. 3 points for 2 days late. If it's 3 days late, 1 plus 2 plus 3 is 6 points. 4 days late, and so on. So early on, the penalty isn't so bad. After 14 days, don't bother, because that's when it crosses the 100 threshold. Why do I do this? Lots of you, everybody here has other classes competing for their time. They have extracurricular activities competing for their time. And I know that sometimes there are weeks where it's just a nightmare. And if you want to turn a program in a day late, most people don't care about the point. They'll take the point, or they'll take the 2 points. And it saves me from having to negotiate with you about, you don't come up to me after class and say, I've got X, Y, and Z, and then I've got to sit there and decide whether, everybody just knows where they stand. The early penalties are cheap. The late penalties for the serious procrastinators are expensive, and it just gradually increases as you go. Okay, so that's the late policy. The grade components in here, the homework problems in this class are really important, and they're going to be hard, and you're going to spend a lot of time on them, so that's about half of the grade. The others are the in-class exams. The in-class exams are not so much, you're not going to be programming in class. You do have to be familiar enough with the syntax to express to me computational ideas, but you're not going to be writing programs in class. But there are several important algorithms that you're going to learn here, different sorting algorithms. You're going to learn Huffman compression in here, and those algorithms are things that you can do on pencil and paper, and those are the things that I'll be testing in class. The letter grade scale there is pretty standard. The cheating and plagiarism statement, you can, I don't know if I said it in here. I meant to say it up here in the homework section. I forgot. You're allowed to work in pairs, at most pairs in this class. Most people choose to work alone. In the past, that's been the pattern. But I allow people to work in pairs in here. If you work in pairs, submit your work to me. Submit one program to me, and in a comment somewhere, let me know that that this homework is really for 2 people, or was created by 2 people, and you'll get the same grade, whatever that happens to be. Cheating and plagiarism. Don't take your program and send it. Evan can't send his program to Luke, and Luke change a few variables and submit it to me. That's cheating. I know that they would never do that, and I know nobody in here would do that, but let's just get it out in the open. Let's not do that. I'll figure it out. I'm pretty, I can usually figure it out. And, if you're having trouble keeping up, come see me in my office. That's what I'm there for. If you're having trouble with a deadline, come see me in my office. Talk to me about that deadline. I mean, I know I said my late policy was designed so that we didn't have to discuss such things. But if you're really under pressure, talk to me before you do something stupid. Okay. So yeah, I'll add that comment about being able to work in groups to the policy, but keep that in mind. Let's see. A little bit different from those of how many people have me in 167 last spring? Raise your hand. A few of you. So those of you that had that class know that I had you submit your work using a Dropbox folder that I shared. I'm changing that procedure this time around. I'm using a web page to upload files to me, which seems to keep things more organized than just letting you populate your own shared folder. So you're going to write a program, you're going to browse to that file, you're going to pick it. I'm not going to do it here. You'll pick it, you know how to do it. You type your user ID in here, that's how I know who this is and where this thing's coming from. You're going to pick what homework it's associated with, and you're going to click submit. Go ahead.
For partners, would you want us to just do like
one, and I'll figure it out.
Okay. Like in the make a note of it in the program. Don't worry about it.
Yeah. So you would just put Edison there.
Yeah.
And then in the comment at the top, you would say, you know, Ben also helped me on this, and then yeah, I'll figure it out. Okay. Questions about that?
Are we uploading like a zip or all the passwords?
No, one file at a time. Yep. It's not going to be too bad. I don't think there's any program in the semester that has more than 5 files associated with it. So we'll just plow through 5 files and put it in there. Those are the baseline kinds of policies. It's early in the semester. We'll just see how it goes.
I'm assuming if you upload something a second time with the same
file name, it will be overwritten. Yes, you're absolutely right. I will not know that the other one was ever there. Yes. And don't try to guess what each other's file names are and overwrite them with blank files. Okay? We're all in this together. So I don't have any kind of security in that sense. If you guess, like you all know each other's user IDs. And if you put somebody else's user ID in there and you guess like, I don't know, stack.cpp, you can probably blank it out. Okay. That said, once you submit that stuff, there's no way for anybody but me to see it. So it's perfectly secure in that regard. It's just not secure in the actual writing of the file. I could implement a password system, I just didn't feel like it. Okay. So let's talk about this programming environment that we're going to be stuck with, at least in the beginning. How many Windows people in here? And Macs? I can see several of them. So I've got a slight Windows majority. I'm going to talk. You can see I'm running Windows here. I'm going to talk about Windows at least to start with, and then I will briefly talk about Mac at the beginning. There's only one difference here at the start between Mac and Windows, and then everything else will be the same. So I'll start with Windows. The first thing you need to do is access the MATLAB. You need a command prompt access to the MATLAB. The program that we're going to use for that is something called PuTTY. So you go to Google, you type in the word PuTTY. And remarkably, it's not PuTTY for caulking bathrooms. It's literally the first hit is the program that we want. Now I don't know if that's Google knowing me really well and knowing that I don't want to see about bathtub caulk. I want to see about PuTTY. I'd be interested to hear your experiences. But what you're looking for is this. The first link for me is the right one, the PuTTY download page. And you're running Windows, you go down here, you want putty.exe, you right click on that, you save link as, and I recommend just, for the start, just put it on your desktop. And there it is. Now, unlike a lot of programs that you get from the internet, this guy is ready to go. It's a fully functioning binary, it doesn't need to be unzipped, it doesn't need to be installed. So you have it on your desktop, you click on it. Now, this is not the first time I've run PuTTY, so I've actually generated a couple of profiles that are helpful to me. Those you can ignore. It's asking where do you want to connect to? And you want to connect to math.whitman.edu. This is a computer associated with the MATLAB downstairs. You type that host name in there, math.whitman.edu, and you hit enter. And you're going to get a window popping up, and it's asking for a login ID. This is your MATLAB user ID, which 99.9% of the time is the same as your Whitman user ID. So I'll put mine in there. And you hit enter. And after a bit of thinking, It asks for your password. This is your MATLAB password, not your Whitman network password. So you have to actually have a separate MATLAB account. It just so happens that when we generate MATLAB accounts, we use the same user ID as your Whitman network ID. So I'm going to use my MATLAB password. And now I'm logged in and I'm at a command prompt. For Mac people, some of you sitting here with your Macs already. The Mac people, this is a slightly different thing. What you want to do in a Mac is go to, I think it's Applications Utilities, and run the terminal program. You run the terminal program and you get something that looks quite a lot like this. The only problem is it's a prompt on your computer, not on the MATLAB computer. To get to the MATLAB, you run your terminal program and then you type SSH and then your user ID and then math@math.whitman.edu, like that, and you hit enter. And it's going to ask for your MATLAB password. It might also yell about keys and stuff like that. Just say yes to everything. Okay. Once the Mac people have run the terminal and they've run this SSH command, they are in exactly the same place as the Windows people. All right.
Does the SSH work?
From a command terminal, I don't think so unless you go out and install it. The cool thing about Mac is it's already installed. And so that's why we went and got PuTTY. Alexander, did you have a comment?
I would say, yeah, you do have to have PuTTY.
Okay, yeah. And
We all access, so we're all accessing the same computer, right?
yeah. Now, let's talk about this. And my whole 167 class is accessing this computer. So, for example, if I type users, there's already a few people on there.
You're on it twice.
Yeah, that's okay.
Well, Lou.
Now, I log into this thing, and there are 38 people logged into Math, all running VI and writing their programs. Maybe you want a little privacy. Maybe you want a few more CPU cycles. There are a whole bunch of computers that you can get to from here that you can't get to from there, the outside world. So Math is open to the outside world. Once you get into Math, Math is now can go around the internal network. And there are 24 computers that you can, 25 actually, that you can get to from here that are useful. So if I finger at Math like that, in fact, we've all got this down, so I'm going to run a terminal that's much more pleasing to the eyes. Oh, I didn't want to go to caret. Dang it.
Do you have to do anything when you want to log out besides just shutting down the terminal?
No. Okay, so here I am at Math. If I finger at Math, I get a list of all the computers that I can log into. So if you log into Math and things are running a little slowly, or there's a lot of people, you can just type U, or there's a lot of people logged in, you can finger at Math, and I don't know if you noticed, but not only does this give a list of all the computers in the MATLAB, but it tells you who's logged in. For example, Root is logged in on Aries right now. So you can actually look at this list and find empty computers. They're all identical, so pick one. I will say, let me think about this for a second. The bottom 9 down to Zeus, so 1, 2, 3, 4, 5, 6, 7, 8, 9. From Nemesine down to Zeus, those are new computers. They were purchased just last summer, so they're faster than the previous 15 or so. So if you really want high performance, I don't think you're going to notice at a text terminal. The bottom 9 are the newer, faster ones.
I was just curious, how is this functionally, if you SSL from here, aren't you going into math and then into one of these computers?
Yes.
Isn't it going through math, so wouldn't you get negligible performance increase?
Oh, no, all of the processes are running on that computer. All I'm using is the network to see what's going
I think network might be
on.
the limiting factor here.
You think what?
Network might be the limiting factor rather than process.
Not even close.
Okay.
Yeah, not even close.
If you're compiling, that's true.
All we're doing is sending these little ASCII characters through the network. This network can run at 100 megabytes per second.
Personal experience recently with the server, but
Yeah. Okay. So you could have 100 people running on math, and then you decide I'm getting out of here. And now I'm on Zeus, and there's nobody here except me. And you could pick any one of those computers. You can also do map at math.
You just do SSH.
And it's just SSH and the name of the computer. Once you get to math, you don't need to add that extra user ID thing, shulaw@math.whitman.edu. Once you're in math, then you can just SSH to the host directly because it knows who you are now. Yeah, this is a map, and again, it'll show who's logged in where on each of these consoles. Okay, so now you're at the terminal. What do you do? So not many people have experience with this is the Unix command prompt. Let's talk about some of the things you can do. All computers, I can think of no exceptions. All computers are essentially collections of files and folders with instructions that are executed in order in some way. And where you are right now is you're in this massive file cabinet, right? Imagine we had this giant filing cabinet right in the middle of the room here. And I just had a diving board here. I jumped up and I dived in. Okay, the filing cabinet has a bunch of manila folders, and inside each manila folder are pieces of paper, documents, and so forth. And this is a kind of a slightly sophisticated filing cabinet. Inside each manila folder, there are also other manila folders. So, imagine I have a diving board here and my giant filing system here, and I jump in and I land inside one of these manila folders. I look around me. What do I see around me? Files and folders. Okay? What I've done by logging in to math here is I've jumped into the filing cabinet and I've landed in a folder. If I want to see what's around me, I type ls for list. Let me interpret some of that for you. The blue files are directories or other folders. These are other manila envelopes that are sitting inside my manila envelope. Everything else is just a file. These are documents that somebody decided to store in this particular folder. So ls is an important Unix command. It's probably the first one. That's why I showed it first. It's the first and foremost command. It lets you know where you are, what you're doing. So it's not really important which particular folder you landed in when you logged into this computer. That's not really relevant because you don't own anything else anyway. All you own is what's in the file that you landed in. But everything that you see here is yours to do with whatever you want. The next most important Unix command is the change directory command. I can enter any one of these directories. I'll enter the Spring 2013 167 directory, which I created earlier in the day when I was teaching programming. So I type cd spring-2013-167 and I hit enter. You'll notice that the command prompt has changed. The green text now shows that I'm no longer sitting in the default directory, but I've actually dove down into a subdirectory. How can I see what's around me in this one? ls. And there are no files in this directory, and there's one folder, homework 1. And I was just showing them how to do their first homework assignment. If I want to go see what's in homework 1, I can go in there and then I can look around. And there's hello world. Memories. Okay. If I want to go back up, so the way I look at this is I started out in this top level directory, and then I went into this folder, and it had a folder inside of it, and I went into that folder. Now I want to go back up. There's a special symbol for that. CD space 2 periods, right in a row. That tells me to move up one directory. And I can do it again. And now I'm back where I started. So down here in Spring 2013 167 homework 1, suppose I know that I just want to go back to the default directory. I could also just type cd with no arguments and hit enter, and it'll put me back at the default level. So you can get yourself out of any jam just by hitting cd, and it'll put you back where you started when you logged in. Okay, that's cd. Now, you're not in Math167, you're in Math270, so you're going to have a lot of programming assignments this semester, and you want to keep yourself organized. So let's talk a little bit about organization. Probably what you want to do is make a directory or a folder. MKDIR stands for make directory. And call it something related to this class. So I'll call it Spring 2013 270. And if I look around now, I see that there's a new folder in this folder, and it's called 270. Yeah?
Is this, like, did you just make the folder inside of your user folder on that?
Yes.
Okay, so we don't have to worry about naming it with our username or anything.
Right.
Okay.
And the beautiful thing about this is if I decide to go bail out and go to one of these other computers, it's there already. So this folder is actually being automatically distributed to all of the other computers in the lab, and there's nothing you have to worry about with regard to that. So all of these computers are functionally equivalent. Okay. So I've created Spring 2013 270. You notice every once in a while it seems like the thing is typing itself. Yeah? So I typed Spring. Mostly I typed S and I hit the tab key. And what happened there? Auto-completion. But it didn't complete it all the way. Why not? There are two possibilities, right? And if you hit tab, if you hit tab again, it'll actually tell you, hey, dummy, you got to pick one of these. And then you can pick one. I'll type 2, and then I can hit tab again, and it'll finish typing it for me. This command line is the result of 40, 50 years of computer science use. And if you learn to use it, it beats the living crap out of a graphical user interface in terms of efficiency. It's really remarkable. If you learn how to use it, you can do really amazing things with it. All right, so let's change into that directory and look around. There's nothing there. Let's make a directory, call it homework 1. Now we see that it's there. Let's go into that guy. H01 instead of H1. Why did I do that? Well, looking ahead, I suspect that there's going to be double-digit number of homework assignments. And I just know this file system well enough to know that you get annoying things like this happening. Let's make homework 10, and let's make homework 2. And this thing is sorting these directories alphabetically. And it's really annoying to me, the anal retentive kind of person that I am, to have H2 after H10. And the way to fix it is to pad by 0. So you do H01, 02, all the way up to 09, and then 10, 11, 12. Why do I not do 001? Because I'm not going to have triple-digit number of homework assignments for you. Yeah, good thing, eh? All right. So I've got some extra homework directories in here. I can get rid of them with the command rm dir. And they're gone now. So you can see ls is really important to remind us what's going on in our folder. You're going to find as you go on, you'll start keeping track in your head, and you won't be using ls very much. You'll know what's in your directory, and you won't have to ls to see what's in there. These basic Unix commands, there's a tutorial here in the supplementary exercises I've asked you to look at. Only sections 1 and 2 of the tutorial are really important. The rest of them are more sophisticated topics that maybe if you're interested in you can read, but we're only going to need the first 2 chapters. And I will certainly try to remind you of different commands as I'm teaching. Okay. I can't remember. Did I do a complex class with you guys in programming last semester? Did I? Okay. That's where I want to get to by the end of today. I want to remind everybody how to build a class, and I'm just going to use a simple complex number class to do that. And along the way, most of you used code blocks. We're not using code blocks, at least not for the first week or 2. I want to show you how to do all of the things that code blocks was hiding from you by hand or from the command line. Oh, and another thing, you can have as many of these terminals as you want open.
Are you going to send out a list of like applications that you would recommend downloading onto your assuming you're running Ubuntu or something? Because
It's out there.
If somebody's running Ubuntu, they should talk to me, because some of this stuff is a little different, and it may not be all there. There's a meta package called Build Essential that will install a whole programming environment for the command line that is really useful. So you should talk to me if you're running Ubuntu. If you're doing Mac or Windows, everything that you need is right before your eyes here. So here, now I've got 2 windows. This guy is back in the default folder, and this guy is down in the 270 folder. Now I'm in the 270 folder, there and there. Okay. Let me remind everybody how to write a quick class. I'm going to call it a complex number class. We're not going to do very much with it. I want to get us familiar with the notion of separate compilation and makefiles. And the nice thing about recording this desktop is you can just kind of watch this. You don't have to write much down. And then when you get back to your computer in your room or what have you, you can kind of just pull up the video and remind yourself of how this stuff went. So we're going to use Vim. And the first thing I'm going to do is edit the header file, complex.h. And the name of our class is going to be complex. And it's going to have a public and private section. The private section is just going to have 2 real numbers, x and y, the real and imaginary parts. I guess I could call them real and imaginary. And the public section to start out with is going to be very simple. It's going to have a simple constructor. And it's going to have a pair of accessor and I can't remember what the other Java term is, but anyway, it's going to have a pair of functions for setting and getting these values. So double. Not at this point. So double get real double. Oh, empty. And void set real double. Oops. All right. So real simple class, not even close to what you would want for a full complex class. But this is a nice header to start out with. If not defined, complex H, define complex H, and if. And that's just some standard boilerplate to prevent the compiler from loading this header twice during a compilation. So there's complex.h. Notice I'm not talking much about Vim, which I'm going to expect you to use. Don't worry, we'll get there. I opened that file with Vim and I put a bunch of typewriter characters in it, ASCII characters. I saved it and I quit, and now I have this file in my directory, complex.h. That's file 1. Let's talk about file 2. Complex.cpp. So it's there. It's here that I define all of the things in complex.h. So to do that, I first have to include complex.h, and then I'm going to define the constructor. Yeah. Oops. Okay, so there's the constructor. It's going to take 2 arguments. It's going to take the first argument and put it into the real slot, and take the second argument and put it into the imaginary slot. And then I don't remember what else I had. Okay, so let's get this guy. And this guy. This guy. And the last guy. Should be able to compile this guy. Let me write it and quit it. I can compile this thing without creating a final executable like this. And it looks like it's good. And what that's going to do is create a .o file. This is not an executable. It doesn't do anything at the moment. It's just some instructions for how to build the complex class. And those computer instructions, the computer readable instructions, are in the .o file. Now, if I want to use this class, I get my hands on a main.cpp. CPP stands for C++. And let's include IOStream so we can play around with this class a little bit. And let's include the class. This lets me declare things like complex numbers, for example. Okay, let me declare a complex number z, and let me make the real part 1 and the imaginary part 2. And then just to show you that it's actually working, I'll print out the real part. and the imaginary part. Okay. Let's compile that just to make sure there are no syntax errors. Looks good. Now, I've got complex.o and main.o, neither of which is a fully functioning computer program. Complex.o has the machine instructions for the complex class. Main.o has the machine instructions for executing the main program. But main.o depends on instructions that are in complex.o. To get a final executable, I actually have to link these guys together. Like that. And when I do that, I've got a.out. And that's the thing that runs on the computer.
What does the -c stand for?
-c means compile, but don't link. Okay. And it appears to be functioning. I realize this is a whirlwind review of C++ and class stuff. That's okay. That was my intention. We've got several days before you actually have to start producing code. Let me show you one last thing that is somewhat new. I don't think we talked about makefiles extensively. So you've got this main thing, you've got this complex.h and complex.cpp, and you see lots of painful compilation steps in order to make this happen. What we'd like to do is make it easier on ourselves to compile these things. And so I'm going to edit something called a makefile. Makefile has the same name, so it expects to be in a directory with a bunch of programs that you've written for a particular purpose. So you can't have it, so it's always called makefile. And the makefile is essentially a list of rules and dependencies, things that these rules depend on. So the first thing I'm going to write, the first rule is just how to build the main program. What does the main program depend on? It depends on the existence of main.o and complex.o. If those two guys exist, how do I make it? I do g++ main.o complex.o. If they don't exist, what do I do? Well, I have to have a rule for how to make main.o.
Just so we're clear in this language, the returns are what preference commands.
Let me talk about that in a second. Most of the time what you're going to be doing is starting with this makefile that I'm writing right now, or a similar one, and just editing it, because we're not going to be doing very sophisticated makefiles in this class. Usually just a set of classes and a main file. But yes, I'll talk about that in a second. So what does main.o depend on? Main.o depends on main.cpp and complex.h. Doesn't depend on complex.cpp, right? Okay. If I have those two guys, I do that. What does complex.o depend on? Well, it depends on complex.h and complex.cpp, right? And if those two guys are there, then that's what I should do with them. Again, I'm not going to get into a massive makefile tutorial, but essentially it's rule : and then a list of files that the rule depends on. And then the next line is a tab character and then a command. And then you move on to the next one, it's rule : and a list of files, and then a tab character and a command. Oh, and let me put one more in there that's kind of useful. So clean removes the .o files and the a.out file. So if I type make clean, it's going to go down to that rule and execute it. And you'll notice now all those files are gone. If I type make main.o, that command is executed. The default rule is always the first rule, and it's always the rule that makes the final package. Let me make that. So the default rule noticed that complex.o was missing. And so it ran the rule for complex.o right here. It noticed that main.o was there. So it didn't bother redoing that. Having everything that it needed, it went and executed the main rule and generated a.out. Now you might think this seems like a lot of trouble to go through, but if you have a massive software project and you go in and you change one file, let's say complex.cpp, and I don't know, maybe I put a comment in here. So that doesn't really change anything. If I type make, it's going to notice that that file changed, recompile it, and then regenerate the main program. So what this does is it only recompiles the stuff that changed and relinks the stuff. Again, it's a real time saver and a nice auditing kind of thing. It keeps track of what's changed. I want you to make a makefile like this for all of your assignments. You'll notice that that is actually part of the first assignment. Provide a makefile for your project so that I only need to type make to compile your program. So what you would upload to me in this example that I just showed you is complex.h, complex.cpp, main.cpp, and the makefile. And you would have to do them one at a time through the upload link. And then they're going to be sitting in a directory, and then I can just come along and type make. Let me show you briefly how to upload from the MATHLAB, and then I'll let you go. Links. So Links is a command line browser. It's a text-based browser. And it will go and render this web page that I had already showed you earlier. So here's what this web page looks like in the Chrome browser. Here's what it looks like in the Links browser. It's a text-based approximation of what you see in the full graphical browser. Program or other file to upload. Makefile. User ID. I'm just hitting the tab key to switch fields, and I hit submit, and it says good. You can use the arrow keys to move backward, so go back and move the arrow key. You can use the arrow keys to move around, and just go through this again. Complex.h, same user ID, submit. Back arrow, complex.cpp, submit. Back arrow. What else was there? Main.cpp?
The current directory.
Yes, has to be in the current directory. And again, as we get through the first couple of weeks, I'll show you better ways of doing this. But for now, that's what we're using. And then once you're done with Links, it's a text-based program. There are a few basic instructions down here at the bottom. Quit. You type the Q key. Are you sure you want to quit? The parentheses Y is the default response. I can just hit enter, or I can hit Y, and it'll quit. Sean.
Yeah. So does Links, is it able to render most websites, or does the website have a version that can be used by that browser?
It tries its best, and some are better than others. So here's CNN. And then you can just move the arrow keys around, and right arrow will follow a link. and left arrow will move you back.
Is this how you would like download a browser if you got to the point where you accidentally deleted all of the browsers on your computer?
It would be one way of doing that, yeah. But you probably wouldn't have this browser either. So there's another one called Links, which I don't like as much, but it seems to do a little better on some web pages. And this one actually is sensitive to the mouse, which is kind of cool. And Links is not sensitive to the mouse. So who knew there were actually two text-based browsers out there? And of course, many of you may know I use a text-based mail client called Mutt. And I have yet to find a graphical client that is even a tenth as efficient as my text-based client. Okay, so that's the beginning here. Next time we'll talk about linked lists and get you on your way towards programming. What I strongly encourage you to do today is to figure out how to get into the MATLAB, review the basic Unix tutorial, play around with that. Oh, and I forgot to talk about VI, but there's also a VI tutorial that I want you to play around with. And that is linked also in the homework. And it's got this sort of nifty little Flash interface, and you can just practice VI in this Flash applet. Okay, those of you that have forgotten your passwords, stick around. The rest of you are free to hit the road.
Really quickly, on the thing, in terms of working in the MATLAB, if I continue to work the same hours I did last semester.
Oh yeah, you know what? We're gonna have a meeting maybe tonight or tomorrow. I'll send an email around. It's probably gonna have to be tomorrow because my afternoon is swamped.
I was just curious about that.
But yeah, I'll look for an email from me.
Dude, I have to say the class file system